Today's lesson is about inscribed angles. So last time we had central angles where the vertex was on the circle and the measure of the angle equaled the measure of the arc. But now we have inscribed angles, so this is going to be different. Inscribed angles are angles formed by two chords two chords with its vertex on the circle. I don't know why there's an extra blank here. Okay, so an angle formed by two chords with its vertex on the circle. So if I look at a picture, here is an inscribed angle. So it's got two chords. Okay, the two chords would be AB and AC. Okay. Now, when the angle reaches out, it grabs part of this circle, and this arc right here is called the intercepted arc. And we are going to find out today that the inscribed angle is going to equal 1/2 of the intercepted arc. So unlike last time where the angle and the arc matched, this time it does not. And I want you to notice that it's not going to be as big of a deal today, but it will be a huge deal on Friday. When we set up our equations, we're always going to write it with the angle equals something. So it's always going to be in terms of the angle. Now, before we can do all these, we need to make sure that we understand what the inscribed angle and its intercepted arc is. So there's a few inscribed angles in here. Let's look at one of them. One of them would be this angle right here. It's formed by two chords. The vertex is on the circle. So that angle would be angle B. I totally did that wrong. Take two. That would be EBD. Or you could also say DBE, same thing. The intercepted arc would be this arc right here, the arc that reaches out. So it would be arc. If my pen would cooperate, it'd be arc, oh goodness, ED. Okay, notice that E and D are the first and last letters here. Let's find another inscribed angle. This right here would be an inscribed angle. It's formed by two chords, AC and CD, and its vertex is on the circle. So in this picture, angle ACD is the inscribed angle, and the intercepted arc is this whole thing from A to D. Again, notice it's the first and third letters. Let's see if we can find one more on here. Over here, this is an inscribed angle as well. That would be angle BDC, and the intercepted arc would be from B to C. Okay, so now that we're trying to put together the angle and the arc, let's see if we can solve any of these. So like I said, the angle is always equal to 1/2 of the arc. Well, on the first one, angle equals 1/2 of the arc for inscribed angles. Okay, so the angle is always closest to the vertex. So 40 is your angle, and it's going to equal 1/2 of the intercepted arc. Well, the intercepted arc is AB. Let's just call that X. Okay, well, to solve that equation, we got to multiply both sides by 2. And so we get that it equals 80. Okay, now some of you are going to say, well, Miss Shawn, I do not need to write an equation. Well, you should need to write an equation. You should not need to write an equation. It's very easy to do that math in your head. That said, I want you to get in the habit of writing these equations, because Friday, when we add on all the other different types, it's going to be really important you get in the habit of writing the angle equals and then whatever your equation is. It's going to set you up for being successful later on. So right now, the angle is what we're trying to find right here, and that angle equals 1/2 of the intercepted arc. So it equals half of 150, which would be 75. Okay, now let's look at this one. This is an inscribed angle because it's formed by two chords. Its vertex is on the circle. So the angle, which is closest to the vertex, is 2x equals 1/2 of the intercepted arc. The intercepted arc is 136. Okay, half of 136. I can multiply by 2, but I don't need to because taking half of an even number is not a hard thing to do. Half of 136 is 68, so I get 2x equals 68. And I divide by 2, and so x is 34 in this problem. All right, let's try another one. Over here, we want to find angle MNO. MNO. It's this angle right here. Well, it's definitely formed by two chords. Its vertex is on the circle. Okay, so its angle, the angle, which is x, is going to equal 1/2 of the intercepted arc. Well, let's see what the intercepted arc is. Oh, the intercepted arc is a semicircle. Half of 180 is 90. So anytime the intercepted arc is a semicircle, then the angle is going to be 90. So I don't have to give you any of the numbers. You should just be able to figure that one out. Okay, this one looks a little strange, but let's see if we can figure it out. First, they want ACB. Well, here's ACB. Formed by two chords, vertex on the circle. It's going to be half of its intercepted arc, so it's going to be half of 60, which is 30. Okay, not bad. Angle ADB. A to D to B. Formed by two chords. The vertex is on the circle, so it's going to be half of the intercepted arc. The intercepted arc is 60. It's going to be half of 60, which is 30. Okay, so you probably can guess what's going to happen now. I've got AEB, A to E to B, formed by two chords. The vertex on the circle, it's going to be half of the intercepted arc, so it is going to be 30 as well. Okay, now notice all three of those angles had the same intercepted arc, and they all turned out to be the same. So this rule says if two inscribed angles, so here's one, and its intercepted arc, and another inscribed angle has the same intercepted arc, then those two angles are congruent, or they're equal. Okay, if you want proper notation, you can write it like this. Either one of those things. But if two angles have the same intercepted arc, then they are equal. Okay, so keeping that in mind, let's look at this problem here. We know this angle is 1/3 x plus 7. Well, this is the inscribed angle. It's formed by two chords, so it's going to be half of its intercepted arc. Here's another inscribed angle, so it's going to be half of its intercepted arc. Well, we know that they're half of the same arc, so that means they have to be equal. So that means 1/3, goodness, 1/3 x plus 7 has to equal x minus 8. Okay, we're going to clear the fraction, so I'm going to multiply everything by 3. 3 divided by the 3 in the denominator is 1 times the 1 on top is 1, so I get 1x. 3 times 7 is 21. 3 times x is 3x minus 24. So I'm going to subtract x and get 2x, add 24 and get 45, so x equals 45/2. That's it. So if you have two angles that have the same intercepted arc, then they're going to be equal. Okay, last rule, and this is pretty quick. This one says if a quadrilateral is inscribed in a circle, meaning the 4 points of the quadrilateral are sitting on the circle, that means it's inscribed, then the opposite angles are supplementary. So that means A plus C is going to add to 180, and it means that B plus D is going to add to 180. Okay, I've got two of these. We're just going to try one of them because I think you get the idea. In example 1, this is a quadrilateral that's inscribed in a circle. We know it's inscribed because all 4 vertices are on the circle. So because of that, the opposite angles are supplementary. So these two add to 180, And likewise, these two add to 180. So if you want to solve your equation, you'd have 4x plus 80 equals 180. So 4x equals 100, so x is 25. Okay. And then same thing on the other one. 10y plus 120 has to equal 180. So 10y equals 60, so y just equals 6. I'm not going to do another one, but remember, when a quadrilateral is inscribed on a circle, so the 4 vertices are on the circle, the opposite angles add to 180. Okay, so they're not equal. They add to 180 when it's a quadrilateral in a circle. Okay, good luck with your homework.